Now, I've talked about some of the changes and observations we've had of global warming, and so I'm just going to go through some of them before. So I talked about temperature increasing. So we've had temperature increasing, but we know the temperature is rising, and it's not just one nation / data set saying this. The graph here is showing 4 different international organizations. We've got NASA and we've got NOAA. They're both in the USA. This, I believe, is British. And then we can see the Japanese Meteorological Society. They have all independently been recording temperature anomalies since the beginning of temperature recordings. So 4 independent, well, I'm not going to stick it to 4, it only shows 4. But we'll go with most research data from, independent institutions. All have the same results. And if everyone comes to the same result by studying it in a different way, the odds are it's probably happening. Now, one thing you need, I should also say it's 98 to 99% of all scientists agree that global warming is happening. Now, something you need to take into consideration is looking at the data. If you look at only a small portion of the data and not the whole thing, you may think we're actually not warming, you may think we're actually cooling. But remember, that's looking at weather and not climate. So if we were to zoom in and focus on just this right here, just these days right here, you would actually think the world is cooling. Because look at this, we've got a drop in our average temperatures. Everyone agrees there's been a drop in the temperatures. We're actually below the average, so the Earth must be cooling. But that is less than 5 years. So this is in less than 5 years of data. So what you're looking at is a weather. So it's equal to weather, not climate. And remember, global warming and global cooling are climate. So climate change, this is the warming or the cooling. It's not weather, it's climate. So all these independent institutions have come to almost identical results, indicating that yes, the Earth is getting warmer. Another thing we've seen is what's happening in our oceans. Now, I mentioned that ice is melting and the oceans are rising. So what we know is that the ice at the North Pole and Antarctica is melting. We can see it melting. This graph down here is actually showing us the maximum level, maximum ice in the Arctic each year. So you can see between 1979 to 2000, this is how much of the Arctic was actually covered by ice. Whereas now we can see, ooh, it's a lot lower in 2012 than it is back in our 20th century average. So if we were to look at this here, what does that mean? Well, the green line here, this is, you can't read it here. So this is from 1970, well, this, I'll just call this the 20th century. So this is where the ice maximum went in the 20th century. They are not including Greenland in this, but you could probably include Greenland in this. Whereas today, or in the 2012, they don't have the 2007 here. In 2012, we've lost all of this other sea ice. So we can throw parts of Greenland, not all of Greenland. Greenland is losing a lot. So we have lost a lot of the ice that actually is in the North Pole. And we know that it's melting in at the South Pole too, because we always hear about these ice sheets breaking off of Antarctica. So what happens is when they melt, they actually add more water, which then gets us to rising sea levels. We also have plants, well, not necessarily plants, we're going to say animals that require the ice landscape are losing their habitat. Which means they are on their way to extinction. That's why we have the polar bear here in this image, because the polar bears, they need the ice to get out to where their prey is actually located. And if they don't have icebergs, ice flows, then they can't get to where their prey are and they go hungry. So this loss of sea ice is actually affected our friendly neighborhood polar bears as well. And then again, we get rising sea levels and we are losing coastlines. Remember, the majority of the human population lives on a coastline. So if we're losing all of our coastlines, we're losing most of where all humans currently live. I only showed you the United States. If all of the ice melted on our planet, I mean, you can go and see the map of the entire planet showing you where all of the ice is actually where everything is going to be flooded because of the ice melt. Now, you may think, well, when I add ice cubes to my full glass of water, it doesn't overflow overflow my glass. I believe this was something that a senator once said. When I put ice cubes into my glass, it doesn't overflow. And that's true when the ice is frozen. But if you let the ice melt, it will then overflow. So when we put these ice sheets breaking off and these icebergs breaking off into the ocean, while they're still frozen, they may not actually, oh my goodness, I'm not writing anything. They may not actually contribute to sea levels, but then they will actually melt. And when they melt, then they contribute to sea levels. So I talked about sea ice, but we're also losing glaciers. So we're also seeing glaciers melting faster than they are produced. Now, glaciers actually flow out to the ocean, or they did once upon a time. They don't always do now because they've melted too much. So they actually have, they actually melt into the ocean. This here is showing us, we'll call it, I'm sure they call it an ice sheet, but it's actually part of a glacier breaking off into the ocean. Breaking off into the ocean. So we can see, actually, there's little glaciers here, and there's a little one there. And then this is the big glacier, and it's broken off right there, and then it's going to go float out to sea. And since this has happened in sort of the last century, we actually have pictorial proof that this is actually happening. So this is a glacier in Alaska. You can see where it looked, how far it went in 2013, how far it went in 1913. So in 1913, it actually probably extended to the ocean. And then in 2012, it's pretty much gone. And you can see primary succession occurring. If we look down low where the ice was probably most recently here, we get our pioneer species. But if we look up higher where the glacier has probably been gone the longest, we already have trees. So in this landscape here, you can see what it looked like in 1913 and what it looks like in today. And so we've actually lost a lot of our frozen ice. Well, frozen water. So as the ice melts, it then contributes to rising sea levels, and then we get warmer temperatures, which means we can then get more water vapor into the atmosphere, which then means we can get more warmer temperatures, which then melts more ice, which then gives us more water, which then can, oh, look, it sounds like a feedback loop. So all of this additional water from the ice caps melting can have a huge impact, not only on the sea levels, but on global warming as well, because remember, water is the #1 greenhouse gas. And as we add more water or water vapor to our planet, we are increasing the greenhouse gas water.